Let's take a look at practice quiz number 7 for exponential functions. Number 1 says to graph the exponential function below and identify the key characteristics. So we're given -2 to the x plus 6 power minus 1. So the first thing I would recommend is to type that into Desmos. So let me bring that up, clear out what I have in there. Okay, so let's type in, just like it looks, y equals -2. In the exponent, we want to keep x plus 6 together, so we need to use parentheses for that. And then minus 1. So then I can look and see that it does have a y-intercept at 0, -65. So I'm going to put that over here. It does not have an x-intercept, so I'm going to put none, because it has an asymptote that looks like it's at -1. And I can test that by typing in y equals -1, and I can see that is indeed the asymptote of my graph. So that helps me to sketch the graph, and then I'll pick out domain and range. So I have a horizontal asymptote at -1. My y-intercept is pretty low, so what I could do to show this on the graph is just pick out a point down here at the bottom and just label it -65, and then just draw my line to where it doesn't touch the asymptote but goes through that y-intercept. So for domain, it looks like it's definitely going to the left and the right forever, so I need to put -infinity to infinity. And then the range is going from -infinity up to -1, but it won't ever equal -1. So I'm going to put a parentheses for that one. Number 2 says a population of 230 rabbits increases at an annual rate of 36%. Write an exponential function to model the population of rabbits, and how many rabbits will there be in 4 years? All right, so this is just increasing, so it's just a growth function. So I need to write out y equals p 1 plus r to the t power. And we've also looked at this as having an a over here. It doesn't really matter what letter as long as you put the final amount over there. 230 was our initial amount of rabbits, so I'm going to put that where the p was. I'm going to put 1 plus 0.36 because that's 36% as a decimal. So remember, 0.36 is because I had to move the decimal from 36. Let me start there. We had to move the decimal over 2 places to the left or divide by 100 to get it as a decimal. And then we want to find the population of rabbits after 4 years. So then I can just plug all of that in. So 230, 1 plus 0.36, and then to the 4th power will give me 786.8 rabbits. So I'm going to round that to 787 rabbits because that would make more sense. But if you leave a decimal, that's okay too. And that's it for number 2. Number 3 says your bank is offering a savings account with a rate of 2.5% compounded quarterly. If you deposited $1,600, how much will be in the account after 11 years? And be sure to show the function to represent the situation. All right, so we need to use compounding interest, which is a equals p 1 plus the rate over n to the n times t power. N is the number of years the number of times a year it compounds. So if they say compounds quarterly, that means n equals 4. Then the other variables are very similar to the growth formula. So if we had an initial amount of 1,600, we're going to put that where the p is. 1 plus the rate. So the rate was 2.5%. So if it was 2.5%, we need to make that 0.025 as a decimal. We got to divide that by 4 for quarterly. Keep the 4 the same in the exponent. Then we're trying to figure out how much will be in the account after 11 years. So we're going to multiply that 4 by 11. So I would recommend that you just go ahead and multiply that together to make sure your calculator treats it right. So that would be 44. And then type all that in to get your final amount. So we have 1600. We have 1 plus 0.025 divided by 4 to the 44th power. So we get $2,104.65. All right, since we're talking about money, we need to round it off. So $2,104.65. So that's it for number 3. 4 wants us to simplify using our exponent rules. So we have a 6 that is affecting everything in this parentheses. So we need to sort of distribute the power of 6 to everything and multiply those powers together. So we have m to the 3 times 6. N had an understood 1 that was there, so that's going to be 1 times 6. N in the denominator has 2 times 6, and the little p in the denominator had an understood 1, so that's also 1 times 6. So then we get m to the 18th, n to the 6th, n to the 12th on the bottom, and p to the 6th. So then the only thing we could reduce are the 2 n's because they are the same base. And 12 is bigger on the bottom, and so you're going to end up with n in the denominator. And you have 12 minus 6 would leave you with 6. And so that is it for number 4. And then we have number 5. This is a situation where we want to solve an exponential equation with like bases. So I see I have a 7 on one side and a 343 on the other. But I can rewrite 343 as 7 cubed because in my calculator, I can go over here and type in 7 cubed, and it's equivalent to 343. So I haven't changed what I was given. I'm just changing what it looks like. But that allows me to cancel out the base of 7 and then solve what's left. So I have 3 equals 4x minus 9. Then I just got to continue solving for x. So I'm going to add 9 and get 12. And then divide both sides by 4. And I get x equals 3. And a great thing to do is check your answer. So go back to the top and plug that back in, and you can check and make sure it works. So 7 to the 4 times 3 minus 9. Let me fix that. 4 times 3 minus 9 power would need to equal 343. So if I type that in carefully, I have 7, and then I have 4 times 3 minus 9, and see how that does equal 343, so I've checked my answer. Okay, so that's it for practice.